Right, greetings all, hopes it finds you well as always, and it's now time for a latest update from the machine shop, where we're up to and what we're on with. Right, first up, we have Brian's latest job. He's busily making a custom nut that the boiler department want to go onto one of the stays on 75029's boiler that they're currently busily rebuilding. So he started a lump of EN3, put the hexagons onto it, turned it, bored it to size, and he's now got it set up in the little Colchester, ready to put the threads on it tomorrow morning and then get it finished. Once he's got that done, he's got a couple of stays to do for 75029 as well. So that's the first job we've got to look at. In other news, we've got quite a bit of progress on 806 actually, and I'll just wander down here and we'll show you a bit more of what we've been on with. On 806, you remember I showed you those dome-headed bolts that Brian's busily making for the buffer beam? Well, they're finished. They're done. They're ready to fit. They're lovely, those. They're absolutely lovely. Made from EN16. Brian's put the dome heads onto them and machined the threads onto the shank. As I've said before, this tit on the end here, the idea is that's twofold. First of all, it's giving him something to hold the bolt by while he was machining it. The second is that it's going to give us something to hold the bolt by when the time comes to tighten it up. Once they're in and tight, we'll simply flash it off with the grinder, dress it back, and you'll be left with a dome head. For those who have not seen these or wonder what on earth I'm holding the camera at, we're doing these as bolts. Originally they were rivets. The problem is, when that buffer beam was riveted, when the LMS made for 806, that piece of steel plate was flat on the floor. There was nothing else in the way, no cylinders, no frame plates, no nothing. It's now on the locomotive, and we cannot, in some cases, get riveting tools in to the backside, to the rear of the buffer beam to re-rivet it. So we came up with the idea of using dome head bolts. Externally, they look just like the rivets they replaced, but they're much easier to fit. And let's be honest, they're actually possible to fit. So that's that job and where it's up to, and it's nicely done that, so they can start going back together next week, hopefully. Right, in other news, another piece of 806 news, the Superheater Header, which we've had on the horizontal borer for heaven knows how long, is finally, flaming hallelujah, finished. The last of the holes have been re-skimmed today. These are the sockets into which the superheater elements go. All of those have been skimmed with that countersink cutter you can see in the spindle. This is just to clean them up, put them back to round, restore the angle in quite a few cases, remove some damage in several other cases, and so that is now done. It can come off the machine tomorrow. The only other jobs it needs is when we get to refitting the elements into it, all of those sockets will have a quick lap just to present a perfect mating surface, or as ideal a mating surface as possible, to the elements, and so that it can be refitted into the boiler. It's also had all the steam pipe flanges recut, as I've shown before. It's had the main steam pipe flange remachined to remove a quite impressive delve, and it's also had a die nut put down all the studs. So that is now finished. It's been finished today. That can come off the machine. The minor entertainment we've had to do the last bit is, as I mentioned last week, the travel of the table on this machine is slightly less than the width of the superheater header. So what I've had to do is, if you remember last week, I had it set up with the base roughly here, and that angle plate was on the other side of it. Well, what I've had to do today is unbolt it from the table, physically slide it across, put an angle plate now on the other side of it. That angle plate is there purely as a stop, just to stop the header rotating and trying to move on the table as we're machining it. And then I had to pick the holes back up again and start cutting. And as I said, they've been finished today. So that job is done, finito, ready to go. Okay? Another job which is in progress, but unfortunately there's a slight pothole on the road of progress. That's the big end shells for the steam crane. These have been remetalled due to wear, and I'm in the process of boring them out to size. This is the first set to be done. This is the left-hand side. They were bored out to size, radii put in, it was all going very well indeed. And then suddenly, on the last cut, the Mustana lathe decided to stop working. We've had a visit from the railway's electrician. What we found out is that there's a contactor in a electrical service box on the back of the machine that's decided rather helpfully to expire. Now, I've spent part of today, I spent on the phone to a very obliging gentleman called Lee in Birmingham, who works for a company called BSA Machine Tools. They're the UK agents for Mustana, and Lee's fairly confident he can supply me with a contactor either off the shelf or, if necessary, brought in from Russia. So that's a little entertainment that we didn't need, but hey-ho, these things happen. It's led to a few extraneous jobs because you'll realise the machine's butted up against the wall behind it. The other side of that wall is the runway for the bandsaw, so part of yesterday's entertainment was drag the runway out of the way so we could then get the door open in the wall, so we can then get the door open on the machine, so we can then put the electrician into the box to find out what's wrong with it. So, yeah, it's never a dull day here. So anyway, that's one set I've done. I've spent today making sure that I can machine the other set in the Harrison if we don't get this lathe repaired immediately. If we have to bring spares in from Russia, they're not exactly going to be here first thing tomorrow morning. So if the next set of shells will probably be done in the Harrison just to keep the job moving. But that job is well ongoing, and we've certainly got one set of shells there that can be refitted. Okay, so what else we've got to look at? Not much, really. Other jobs that have been done. You've seen Mark Lacey has been busily sorting out drills for the fab shop. That job's still ongoing. He's in the process of sorting out that's a full set in 16th-inch increments he's sorted out. What he's got left to do is a couple of tapping drill sets. So we've sorted out a set in Whitworth, and he's currently in the middle of sorting out a set in British Standard Pipe. And then the last thing to look at is another little thought exercise, another of mine. How on earth do we tackle it? And it's this wonderful construction here. Now, buried in the middle of this, somewhere, there you are, you can just about see it, buried in the middle of that is the valve body of the slacker pipe valve for the J27, which I waved a camera at a couple of weeks ago. Now, as I said, last time I showed you this, I was talking about the actual repair methodology, how we could justify it for mechanical means, which was done and dusted, and everyone was very happy, and yes, it'll work. Right, how on earth are we going to do it? The minor entertainment is that there's very few things on this valve which are actually square to each other. The main body of the valve is round, the spindle actually goes at an angle, so the machine face that the valve gland seals down onto is actually at an angle to the body of the valve, as you can see. And so what I've done is I've spent a bit of time jigging it all up on this surface. This is just this angle plate to hold it. Now, the actual machining job is going to be done on the red milling machine. We're going to do it with a series of drill bits and a boring head and a tap, of course. And so this is how I've come up with a way of holding it. The challenge is we had to hold it reasonably firmly in 2 dimensions. So first of all, put this adjustable angle plate and set it up so that when it's clamped on that face there, which is what this big V block here, with 2 studs which go through the back of the angle plate onto the 2 strap clamps there. Yes, I know there's 3 studs. I'll come to what the third does in a minute. So that V block is basically pulling it onto the angle plate. Because the angle plate's set at a slight angle, I've been able, with the aid of a height gauge, to set it so that that face is flat, or sets flat and true in that direct dimension, okay? The next challenge is, how do you stop it tipping like this? Right, we have a chunk of steel here, which is ground, square and parallel. That's held into the angle plate with that 3rd stud that I showed you earlier. You'll see there, that's the 3rd stud. That's got that solidly clamped to the angle plate. We've then got a parallel between it, and then this wonderful piece of ramshackle ingenuity, which is a toolmaker's clamp, which is clamped onto the hexagon of the head of the valve here, and it's clamping that hexagon through that parallel onto that steel block there, which in turn is bolted to the angle plate. So hopefully the whole lot is absolutely solid, can't move, and if my height gauge is to be believed, which I think it is, I don't have any reason to doubt it, it's also held square and true to within a couple of thou. So that's probably better accuracy than it was machined originally. So at some stage next week, that will get chucked onto the red milling machine. We can machine off the old threaded stub, drill out the hexagon, tap it, as I discussed last week, and then make another pipe nip, a new pipe nipple out of bronze, probably LG4 bronze, because it's going to be exposed to steam, and then screw it in, exactly as discussed the other week, and then there you go, job's done, and hopefully it's a suitable repair. So it just goes to show how something that looks quite simple, simply just repair this valve, is actually quite convoluted. There's already a couple of hours of work in terms of planning and justifying the repair from an engineering perspective, and then working out how you're actually going to hold it to achieve the repair. Already gone into the job. We haven't actually cut any metal yet. So anyway, folks, that should be happening next week, hopefully. What it will probably actually work out is it'll be the usual thing of the actual planning of the job takes 5 hours, the actual execution of the job takes 1. That's the way with engineering sometimes. So anyway, folks, I hope you found this educational, informative as always. We're back at it as always, and we're well on with the winter work. In the next couple of weeks, we'll probably start doing some of the annual pin and bush work, so you might hopefully start seeing bits of the standard tank and whatnot coming through the shops. Anyway, folks, I hope you find you well. I hope you find it educational, informative. Take care, and I'll see you around.